So today we're doing Unit 2, Lessons 8 and 9. So we're doing 2 lessons today. And the purpose of those lessons is to talk about something called end behavior. And what the end behavior of a polynomial essentially is what happens to the y values of a polynomial as x gets really infinitely large and infinitely small. So does y increase or decrease? In other words, does the graph go up or down as x gets really, really large or really, really small? So of course, we could figure out the end behavior by just graphing it on Desmos. But what we wanted to be able to do is to learn about how to do that without actually graphing. And that is the purpose of this chart here. Okay. It turns out to figure out the end behavior of a polynomial, all you need, there are 2 pieces of information you need to know. The degree. So the degree, remember, is the largest exponent of the polynomial. So we need to know the degree, and then we need to know the leading coefficient. And if you forgot, the leading coefficient is the coefficient of the term with the largest exponent. So when we look at the degree, we look at, is it even or odd? Okay. And then when we look at the leading coefficient, we look at whether it's positive or whether it's negative. Okay. And depending on that, that will tell you, this chart will tell you what that end behavior is. So let's look at the examples here. Okay, our goal is to figure out the end behavior of the polynomial without actually graphing it. So we have our first example here, x squared minus 2x plus 8. So the first thing I'm going to do is I'm going to identify the degree, and I'm going to identify the leading coefficient, and I will abbreviate that LC. So the degree, again, remember, is the largest exponent of the polynomial. In this case, the largest exponent is 2. So this polynomial is a degree 2 polynomial. Okay. And if we look at the chart, 2, we of course know is an even number. Okay. The leading coefficient, remember, is the coefficient of the term with the largest exponent. So that's this term right here. The coefficient in this case is the imaginary 1 in front of the x squared. So this is a leading coefficient of 1, which if we base it on the chart, okay, it's either got to be positive or negative. So 1 is obviously a positive number. Okay, so to figure out the end behavior, I have an even degree, and a positive leading coefficient. So an even degree and a positive leading coefficient. So this right here is going to be the end behavior of the polynomial. So notice as x gets really small, y increases, and as x gets really large, y also increases. So the way we describe this, the way we're going to describe it is we'll describe it as up to the left and up to the right. Up to the left and up to the right. This right here is the end behavior of that polynomial. Okay, that right there is the end behavior. So let me erase this. Okay, and the good thing about this is you can check on Desmos. So let's take that polynomial and let's graph it on Desmos. So I will graph x squared minus 2x plus 8. And we can see it's a parabola. And notice As we move left, the graph goes up, so it goes up to the left. And as I move to the right, the graph also goes up. So it goes up to the left and up to the right. And that's how we find end behavior. All right. So let's look at number 2. Again, we're going to do the same way. So I'm going to look for, I'm going to look for the degree, and I'm going to look for the leading coefficient. Okay. So the degree is the largest exponent. So in this case, that exponent is x to the 5th here. So we would say that the degree here, we would say that the degree is 5. Okay, and 5 is obviously an odd number. And the leading coefficient is the coefficient of the term with the largest exponent. So in this case, that coefficient, leading coefficient, we would say is 2, which is a positive number. So now I have an odd degree and a positive leading coefficient. So an odd degree and a positive leading coefficient. So this right here is my end behavior. So you can see this one is going to be down to the left and up to the right. Okay, so down to the left and up to the right. Okay. And again, I can go ahead, I will go ahead and show you how that graph works on Desmos. So we have 2x to the 5th minus 5x to the 4th. Okay, minus 30x cubed. Plus 5x squared. Plus 88x. Plus 60. Okay. So we can see here, okay, there's a lot happening in the middle, but as x gets really small, so as I move to the left, the graph goes down, hence down to the left. And then if we move down here, yeah. Actually, we'll go up here, and you can see the graph goes up to the right. The graph continuously increases to the right. So down to the left and up to the right. Okay. Again, end behavior only tells us what happens as x gets really large or really small. It doesn't help us with what happens in the middle. All right. To figure out what happens in the middle, we have to do something else, and we haven't gotten to that yet. End behavior only tells us what happens at the ends, hence end behavior. Okay. So let's lastly look at number 3. Okay. So in this case, my degree, my largest exponent looks like it's going to be x to the 4th. Okay. So this is an even degree. And the leading coefficient, so the coefficient of the term with the largest exponent, in this case is going to be negative 20. Okay, and that is obviously a negative number. Okay, so now I have an even an even degree with a negative leading coefficient. So an even degree and a negative leading coefficient. So this right here, even degree, negative coefficient. So it's going to go down to the left and down to the right. Down to the left and down to the right. And once again, we can go on Desmos and we can check here. We can check and see that we did this correctly. Okay, so negative 20 x to the fourth plus 3x plus 8. And we can see, okay, as it goes down to the left and down to the right. It doesn't tell us what happens in the middle here, so end behavior is not going to help us with this part in the middle. All it does is tell us what happens on the ends, and that is down to the left and down to the right. Your cool down tonight will be a couple of examples just like this.